folks, welcome to free response number 3. So here we have a rational expression and we need to decompose the fractions. We need to get partial fractions. So on the upside, my denominator is already factored. So let's take a look. We have x squared plus 4, right? That is a sum of squares. So I can't break that down. And to kind of give you a counterexample, if that denominator had said x squared, minus 4 squared, then I could have broken that into x minus 2 squared, x plus 2 squared. It would have been a difference of squares. But I had x squared plus 4, so it was a sum of squares, and sums of squares are prime. So I have an irreducible quadratic factor in there. All right, but it's repeated. And I say repeated because you can look at the exponent on x squared plus 4, but when I say the exponent on x squared plus 4, what I'm trying to say, because there's so many exponents floating around, I see there's a squared. So I need to have a partial fraction for each power of x squared plus 4. So x squared plus 4 by itself, and then x squared plus 4 quantity squared. So let's go ahead and we're going to set up our original rational expression, 4x cubed plus 16x plus 7 over this irreducible quadratic factor that is repeated. I'm going to have one fraction where the denominator is x squared plus 4, and then another fraction where the denominator is x squared plus 4 squared. All right, so I'm going to represent each power of that irreducible quadratic factor. And because I have a quadratic factor here on the denominator, I'm going to have a linear factor on the numerator. And I'm just going to change up the letters. So ax plus b here, cx plus d here. And when I start to move through this, if I think about the LCD is going to be x squared plus 4 squared. I'm going to take the highest power I see. And what I'm about to do algebraically is I'm going to multiply this LCD to this expression, right, to the left side of the equation and to the right side of the equation. And when I multiply my LCD to the right side of the equation, I do need to distribute to both of those terms. So let me go ahead, I'm going to scooch this up just a bit, and we're going to go ahead and actually write out all of this algebra. All right, so here we go. So I'm going to go ahead and take my LCD, multiply it to the left side of my equation, and then I'm going to multiply it to the right side of the equation, which means I need to distribute my LCD to both terms on the right side. So x squared plus 4 squared times ax plus b over, just x squared plus 4. Let me go ahead and erase that. And then cx plus d. JK, I gotta multiply the LCD in there. All right, let me multiply the LCD, x squared plus 4 squared now times cx plus d over x squared plus 4 squared. And let's see what cancels, right? Multiplying by that LCD should knock out all the denominators. So x squared plus 4 squared, x squared plus 4 squared. I only have one power of x squared plus 4 down here, so I'll leave one up there. Cancel, cancel. And then let's just kind of see what is left over. So on the left side, I have just 4x cubed plus 16x plus 7. On the right, I have this binomial to this binomial. So x squared plus 4 times ax plus b. And then on the second term, I just have cx plus d. So there's a couple of options at this point. You can plug in different values of x and try and solve a, b, c, and d. What I'm going to do is I'm going to actually distribute all of this out, and I'm going to match the like terms on the left and right side. All right, so if you prefer plugging in values of x, by all means go for it. If I was going to plug in values of x, since nothing happens to cancel too well with this, I might try x equaling 0 and x equaling 1. Those tend to be the numbers I start with if I'm going to go that route, but I'm going to go a different route. So let me scooch this up, and let's go ahead and multiply or FOIL these two out. So I have 4x cubed plus 16x plus 7. All right, x squared times ax squared first, ax cubed. Outer is going to be x squared times b, bx squared. Inner is 4 times ax, which is 4ax. Last is 4 times b, which is 4b, and then I have cx, and then I have d. So what I'm going to do is I'm going to line up powers on the left with powers on the right. So what I mean by that is if I look here, I've got 4x cubed. And if I look on the right, I only have ax cubed. That's the only cubed term. So what that's telling me is if 4x cubed has to equal ax cubed, then a has to be 4. Right, so I can start to kind of strategize and infer what those constants are equal to. And let me scooch this up because we're going to need some more space. So from the cube term, I know a is 4. All right, let me go get the squares. I don't see any squares on the left side, and I see bx squared, I'll go ahead and circle it here, on the right side. So since I have bx squared over here and 0x squared, right, I could essentially say there is a 0x squared here, then that's telling me b has to be 0. All right, so I'm gonna go ahead and erase this. I don't actually need it here, but there's no x squareds on the left side, so b's gotta be 0. All right, let's see about 16x. So here's my linears, 16x, and then I've got a 4ax, and I've got a cx. So 16 has to equal 4a plus c. So let me go ahead and write that out, right? So I'll put a little separation. 16 has to equal 4a plus c. Okay, great. But we already know a. We know a is 4. So that's telling me 16 has to equal 4 times 4 plus c. 16 has to equal 16 plus c. If I subtract 16 from both sides, you can see c is also equal to 0. All right, so I have 3 of my constants at this point. I know a is 4, I know b is 0, and c is 0. That's great. I love when things cancel out. All right, let's put bubbles around the constant. We got 7, I got 4b, and I've got d. So I know 4b plus d has to equal 7. Let's see what we get from this. So 4b plus d has to equal 7. All right, well, we knew b was 0. So 4 times 0 plus d has to equal 7. So d has to equal 7 because 4 times 0 is just 0. All right, so here are my constants, right? D is 7, c is 0, b is 0, a is 4. So when I start to kind of piece that together, and I'm going to scooch this just a little bit back down here, how this is going to play out is I'm going to put a is 4, b is 0, c is 0, d is 7. And I'm just going to simplify that a little. So let me scooch this up one last time, and then I'll start to write all of this out, and I'll get it up on the answer key. All right, so what I'm saying here is 4x cubed plus 16x plus 7 over x squared plus 4 squared. We said it was going to be ax plus b over x squared plus 4, and then cx plus d over x squared plus 4 squared. But okay, again, a is 4, b is 0. So this numerator is actually going to simplify to just 4x. All right, 4x. Great. And then if c is 0 and d is 7, this numerator is going to simplify to just 7. Okay. So this is the answer I'm going to put on my answer key when I scooch this back down, right? So I've substituted my a, b, and c values. Let me move this back down and show you what I would be putting on that answer line. So I would say, hey, Miss Abreu, I went ahead and I decomposed this. This is 4x over x squared plus 4, and then 7 over x squared plus 4 squared. All right. Okay, thanks so much, everyone. See you on the next one. Bye.